Whenever you plan an intervention, for those who practically do it, I have one advice. Do not focus on innovators. When you come with a presentation to a company, let's say you have an audience of few hundreds, there will be 5 to 10 guys asking questions, eager to test it. Make a note, talk to them politely, but do not stick with them because they like new. They adopt everything new. And in half a year, they will adopt something new. Again, that's their life of innovators. They try everything new. Stick with establishment, those who follow the initial hype.
Welcome to AI Ketchup, the podcast catching up with the tech products that matter in the AI era.
Hi, Vadym. My name is Elena, and I'm the host of AI Ketchup podcast. I have seen many articles of yours on very popular websites for IT specialists as well as data scientists. You have been very deeply researching the ways of us to optimize organizational setups. And at the same time, you have paid my attention to what knowledge graphs can bring to us. That is why I'm super excited for our conversation. How do you feel today?
I'm fine. Elena, pleased to meet you.
I really loved when you commented the podcast title. You have mentioned that you have been building ketchup factories, right?
Yeah, indeed. That was a side twist on my career in project management. Back in Nestle, where I worked for corporate business development, it was actually my first experience running business projects after IT projects. So I sold one factory, built another, the one that makes ketchup for dozens of European countries, and have integrated 3 newly acquired factories. That was a very funny experience. And my take out of that is that project management is ubiquitous discipline that is basically a generalized common sense.
Who would have guessed that I would be having on AI Ketchup the person that actually has experience with real ketchup factories? That's super cool.
Yet another funny fact was that it was my first production line which I mapped after that learning was noodles production. So it makes perfect set of spaghetti.
Yeah, I hope that it helps you not to run a spaghetti code anymore.
Oh, spaghetti code is something we will take on later on. And I do have some recipes.
Sounds intriguing. I think that currently you're not dealing with food anymore. You're working at Nielsen and you're probably concentrating your effort right now on analyzing data. Could you describe a bit more on that?
I am a lead data scientist at Nielsen IQ method. And to some extent, I do still deal with the food because we do analyze consumer products. And food is one of the major categories. In Nielsen IQ methods, we develop algorithms which detect patterns in consumer behavior from different sources of data we collect. We are those folks who make core of the Nielsen IQ platform.
Very interesting. At the same time, back at Nestle, you have been working with SAP systems. And then right now you have transitioned into GraphML and you have started looking into describing certain data analysis and data science methods. How has that transition happened?
That was a natural evolution. I started my career as SAP implementation consultant in customer relationship management. And my first projects rolled around retail and consumer goods. Consumer goods is my home industry for nearly 20 years. And currently I work for Nielsen in non-cooperator estimation team. Our goal is to produce reliable market behavior trends at category and brand levels for those retailers who refuse giving data to Nielsen.
Meaning that you are trying to predict the patterns that are not directly given to you in the form of concrete data points, and then you are extrapolating those ones.
Yeah, that's the core of what we do. So we study cooperating retailers and we study consumer panels. Then we extrapolate consumer behaviors from known data to those retailers who do not give us data. So we are quite good at that because usually, as I see, in a few years after non-cooperator estimation had been introduced to a country, those non-cooperating retailers see that we are able to predict their sales and they start cooperating.
That is indeed an interesting way to persuade people to work with you, but that does make sense. Throughout all the career stations that you have had, you have been working with graphs, correct?
That is true. I started as a specialist in customer relationship management and project management. And those entities we are dealing with are highly interrelated. For example, a project plan is a huge pile of work which is broken down into work packages and individual activities which are linked one to another. And that makes an execution graph. In marketing, when we plan a promotion for some product, which results in discounts at points of sales and some promotional activities when samples are given to people at entrance of supermarket, this has to be coordinated with media activity and production of point of sales materials like posters, newspaper advertisement, and so on. So all those interrelated facts also make a graph. Yet another topic that I learned early in my career in Nestle's SAP implementation was organizational change management. Taking organization as a set of networks where we can reason about relations between people, like organizational charts, where we map reporting relations, business process flows, where we have pieces of works executed between individual contributors or departments, and flow of processes between departments. All that makes an interconnected picture which is modeled as a graph. So transition to GraphML was rather evolution of what I did before learning about GraphML as such. I had problems like how do we compare two different projects? Which one has bigger complexity? Or we have to choose 5 projects which will be easier to execute among 10. How do we figure this out? Or questions like, I am going to implement a new enterprise system. Say, we are going to introduce sales automation. That means we bring some CRM box, some set of processes to exist in an organization, and we have to change the way how people work, the way how organization is structured, because bringing new processes has effect on organization structure. We introduce such concepts like hierarchies of products company produces, and all that raises question. There are people, they are doing their work. Whose work is going to be impacted the most, so that those stakeholders have to be tracked individually. We want to find an answer to a question, who is going to be resisting the most? And those who are the most impacted usually resist the most. Not necessarily there are folks who resist change just because they like resistance. But from project management perspective, in machine learning slang, it will be cluster. And stakeholder is a person or part of organization affected by project or that can affect a project. So we want to put them into homogeneous groups and address each group with personalized message. Because we cannot work at personal level with every single stakeholder. We have to group them somehow. And graph machine learning helps do that with help of mathematics other than doing that by thinking. I traded my hair to solving those problems.
It does make sense. And at the same time, I think that for majority of the listeners of the podcast, knowledge graphs are the things that are related to mind maps in a way. So you would have a certain node that is in the middle, and then you would have certain nodes or certain branches that are coming out of this concept. From what you're describing, the practical applications of knowledge graphs were either centered around products or around people and stakeholders in the organization, or if that is about providing personalized services or products to someone, then probably combining both. that is extremely interesting. And at the same time, I would like to also take a step back and think about what knowledge graphs are and how should listeners think about them.
That is a great question. Let's roll back and introduce the concept of knowledge graphs. Let's think about two facts. Elena likes mountains. Vadym likes mountain biking. Those are two facts about ourselves. And each of these facts is structured as three pieces. Subject, who does something, and this is a predicate. In case of Elena, it is likes. In case of Vadym, it is likes as well. And there is object. What do we like? So this structure of triplet of subject, object, and predicate makes an atomic piece of knowledge graph. So it is a fact written in a form that is naturally comprehensible by humans and machines. And when we make huge collections of such facts, for example, Germany has mountains. Portugal has mountains, but they're smaller. At least we do have ocean. So collection of such facts makes a knowledge graph. And on top of that knowledge graph, we can do reasoning step by step. If Vadym likes mountain biking, and mountain biking happens in mountains, there is high probability Vadym likes mountains. We can answer longer questions and have a chain of reasoning when we have facts stored as a knowledge graph. That's a traditional approach to knowledge graph. And nowadays, we have neuronal methods of working with knowledge graphs where we train neuronal networks on patterns of interactions between subjects, objects, and predicates, so that we can train a neuronal network on a number of facts, and it will be able to predict what else does Vadym like if he likes mountain biking. Perhaps it's bikes and outdoor activities. So this can be not only explicitly, this kind of facts can be extracted not explicitly from knowledge graph, but implicitly by neuronal network that had learned lots of patterns.
And now when it comes to using machine learning and neural networks to predict I would probably stick to the word node, so the next element, the next atomic component of a knowledge graph, it would be also interesting to think how currently with the wave of generative AI, two things can be combined. And on the things that you have observed in the bigger enterprises, on how they can deal with information in better ways if they combine both technologies. Do you have certain practical tips for people considering this?
I have witnessed evolution of this approach of combining structured and unstructured data use in enterprises since early 2000s. And one of the flashbacks that I'm having right now is that picture from the presentation when we had a picture that was similar to Boston Consulting Group matrix with two axes. One was structuredness of information, and the other was proprietary. On one axis of this classification, we have proprietary databases where information is structured and belongs to a company. On the other pole is unstructured text and media information, multimedia items like pictures, videos, sounds that we can find on internet. And back then we had very different approaches to dealing with such information. Now we are at the moment of technological convergence. A company can build a knowledge graph as a way to store their proprietary information, and they can use language models trained on internet scale corpus, which learned to reason from what people have discussed all over internet. That's quite an amazing fact about big models. And the synergy between two components is like having two very diligent servants at your disposal. So imagine you have a master librarian who knows every single fact and where it is stored. So you ask a specific question, it delivers you a precise answer. And you have the other servant, which is a universal interpreter that can speak any language and wrap up facts about whatever you want to the level of your audience. And that is a large language model. So you can take some facts from enterprise knowledge graph, feed it to language model, and ask it to make a story for your target audience, be it 5 years old or senior executives.
So we are having the librarian that knows the facts and the certain executors and can bring these books to us when we need them and in the form how we would like them. At the same time, we know that LMs do tend to hallucinate, and that is the big elephant in the room of any executive that wants to bring LLMs to their enterprises. Would you say that contextual AI and the usage of knowledge graphs is something that can help in LM-driven applications that are relying on knowledge graphs?
Knowledge graphs provide facts, and they set borders for LLM to deliver their responses. You can greatly increase factual correctness of answers when those facts are derived from fact storage, which is a knowledge graph. It is when we interact with a conversation system, we want to receive an answer to a question. Then knowledge graph provides us the skeleton of the answer, which is hard facts based on knowledge. And LLM just puts some meat on those bones. Real facts, which are core of the message, are wrapped in a language that by design is acceptable by people.
I assume that it could be helpful for us to relate to this concept if we would be thinking about certain areas. So I'm personally aware of using knowledge graphs for identity verification. I have seen the applications of knowledge graphs also in the space of life sciences when we are looking into protein folding or when we are looking into the molecules that should be combined for certain pharmaceutical products. However, would you say that there are other areas that we could look at and at the same time to understand how we could utilize both worlds of generative AI and knowledge graphs there?
Every software product goes through normal evolution. We start with some prototype, then eventually we sell it to first customer. And it is not very common to have a perfect match of a product to customer immediately. So there are changes coming to the product. And then this product is growing. Once we have satisfied our first customer and secured our relations, we want more customers because we want growth. Surprisingly, new customers have different requirements. Our product has this steady process of evolution. At some point, we end up with different versions of products for different customers. And then boring guys from finance come and say, hey, folks, that you're supposed to build an asset and maintenance cost for all those custom pipelines, they are quite high. Why don't you put everything into a boxed solution so that, folks, you have to build a universal platform that satisfies all our customers and make it configurable. And IT folks say, okay, now we have to harmonize this huge repository of codes into one main branch that would contain everything. And this is a case where we can utilize both knowledge graphs, which are built from code. If we follow good software building practices, our implementations for different customers would have similar structure with some specific components. There can be differences in input and output format. There can be difference in process execution steps. Yet, if we follow some good practices, we have identical naming conventions throughout pieces of code. If we do, we can build a knowledge graph and relate entities of our projects. It is starting to make UML diagrams from code. We can reverse engineer code with help of LLMs, and we can build entity relations diagrams into a knowledge graph. So such knowledge graph can help us understand what is the difference between particular implementations. And it helps us focus our effort in bridging gaps between implementations so that we can run a number of analyses and identify what are the core components used across multiple implementations. What are the most used components across different implementations? What are the differences? And by highlighting those differences, we can focus our developers' effort into making those differences part of a generalized solution. Otherwise, just imagine a situation of inheriting a repository which is many years old with thousands or hundreds of thousands of commits, which is sparsely documented. It becomes mission impossible if we use traditional approaches of code review and manual documentation. So LLMs and code, everyone calls it AI, but those are big models. Let's call it code helping software. Assists us in making proper documentation out of code, helps us break down spaghetti code into digestible chunks, and helps us in documenting and making sense out of that. Also, a big enough model can extract relations and help us build knowledge graph out of this repository we have theoretically inherited. And all that makes ownership of this product easier, and finally helps to convert this huge pile of code from a liability to an asset. Because once we harmonize code base, we have less effort to maintain it.
How helpful it can be if you are having a knowledge graph of dependencies between your huge software project, and then you understand that this function is interacting with that function, and this instance is needing the class of this instance. That is extremely interesting. And if I would think about not only software developers, but also about certain processes that are very often repeated in the enterprises, let's say the onboarding of new employees, or let's take the example of, for example, dealing with the payment that has been delayed. Probably the ID of the employee or the number of the invoice is changing. At the same time, the knowledge work that is happening on the background is having certain steps. You are pretty much having the skeleton, and then the projects are being deployed.
Yes, indeed. When we talk about repeatable processes and everything that is repeatable in an organization eventually crystallizes into a process, be it formalized or informal. It consists of certain steps. And for example, when we talk about new hire onboarding, we have something like a learning map, which is a journey of steps where we can have twists, conditionals, etc. And yes, such description makes a perfect graph. We have been dealing with workflows, at least in SAP world, for quite a while, as well as that drawing relationship diagrams is quite an old school technique, and it is very well advised to have those diagrams drawn before we start coding.
I would agree.
I tried. Having processes mapped as knowledge graphs is on practice, not new, because there is a whole community of business process management, people who specifically do this kind of jobs of mapping activities, find process flows, optimal modeling is not that new, yet bridges between community of graph theorists, knowledge graph folks, and business process management folks are very rare, at least in academic research.
That is rather sad that those two parties are not collaborating.
That's just different schools of thought. Essentially, they talk about graphs. And yet, some of those folks may not have learned the graph notation or may not even know that there is a huge mathematical apparatus behind graphs. It's not only just drawing a business process as a network. It's just making a representation that's nicely consumable and can be machine readable. Next step is automatic finding of bottlenecks, comparing processes, finding deviation in processes. That's very easily addressable with graph representation learning and can be condensed down to a downstream task. For example, let's get back to cooking. If we do pancakes, it's the most simple dish I can come with. We need to make dough out of water, salt, flour, eggs. We have to let it settle. Then we have to prepare our cookware, set up some roasting plate, roast pancakes. And if we have processed things correctly, our pancake is good enough, sometimes even from the first attempt. And finally, when we have baked this pancake, we need to take a decision where to put it. Does it go to plate to be served to our friends, or we have to throw it into the dustbin? That is basically a schema of quality control that is widely used in food manufacturing. And mapping food production processes like a series of interconnected steps with control points has long history, and it has been invented by NASA in the 60s. And they discovered the necessity of delivering safe food to the orbit. It's very undesirable to deliver unsafe food to astronauts who live in a confined space for a long time. You have to be 200% sure that food is safe.
When it comes to organizations and also employees that are working for those organizations, I recall interesting things that you have been writing in one of your articles that was going around employee personalities being like vitamins and being able to influence the organization in some positive ways, but under specific conditions. And I also recall that you are calling organizations living organisms. What would you say are the recipes that, or the descriptions of the processes that can help organizations deal with certain challenges that employees are facing in this living organisms?
We try to describe an organization as an organism. We basically borrow this idea from Ishaq Hadizis. And main assumption is that past behaviors, they predict future behaviors. If a specific person had acted beneficially for situation under specific circumstances, then we can guess that highly likely, given the same situation, they will act somewhat alike. And those companies that have a long history and that have collected records about who in specific situation acted in a specific way, they can convert this knowledge into digestible format for machine learning algorithm that will allow some decision making about future behavior. For example, capacity for a person to take a more responsible position. And this has many concerns, because whenever we talk about people analytics, people dislike it. We humans, we don't like to be watched. We believe that we are free agents having free will and free to act without any observation. This has to be addressed very carefully, and yet graph algorithms deliver quite powerful value even without use of personal data. For example, when we have some business transformation project, we want to change organization behavior. We want to identify successful change agents. So those persons who have to influence organizations. And traditional approach would be, okay, let our managers be the champions of change. Everyone is going to copy their behavior, and that is it. That is how many transformation efforts have failed. And for example, Boston Consulting Group claims that 3 out of 4 information technology interventions in companies fail due to non-technical reasons. So it's people factor that makes ideas fail. And a recipe for choosing successful agents of change is quite simplistic. We have to look into their interpersonal network. And it is not my discovery. It is a brilliant research by 2 ladies. We'll bring a link in the comments section. But the core idea is that good change agents have a star-shaped topology of interpersonal networks. So they have broad set of interpersonal connections with people who are not connected between themselves. They bridge gaps in organization. And the logic is that if we put such folks into change agent role, they can convince every stakeholder in their personal network to adopt new change. And as those folks around them do not have interpersonal relations, they are highly likely not going to make a coalition against change. And that makes difference between choosing a leader of opinions or informal leader for a position of change agent versus a formal manager of part of organization. Usually folks working within a department have some interpersonal relations, and they can sabotage whatever introduction of new concepts that they dislike. There is an old saying that corporate culture eats your strategy at breakfast. When working on such projects at key points, I always challenge my customers, folks, how much data can you bring on the table? How deep can we survey your organization? And it appears that we can draw quite powerful insights without touching people's personal information. Only structural patterns alone are quite powerful. If we add some classification information like job specifics, any other information, it helps. But structure alone is a very powerful predictor.
On the topic of introducing certain procedures into organizations and how people are often prone not to have them being observed or measured with technologies that in theory could have brought positive outcomes for the organizations. We can also see right now how the EU GDPR regulation is impacting us based in the European Union, as well as currently a rather recent regulation on EU AI Act. Would you also see the positive or more of negative impact on the enterprises that you have been working with?
In Europe, we are at forefront of personal data protection. GDPR is extremely strict. It explicitly says data can be collected for specified purposes only, and it cannot be used for any other purpose. It cannot be shared with third parties unless the person who gives this information allows code. There are regulations about data storage and data processing. Makes people feel safe, which is good for social health. As for those who build technology, this is not making their lives easy. GDPR imposes specific rules for data storage processing and extremely high fines if something goes wrong. Recently introduced EU Act contains some funny statements. For example, it protects us from unwanted surveillance. Technologies like emotion recognition or face recognition in public spaces are prohibited. Any kind of decision making based on automatic profiling is strictly regulated. This is good because it brings us to the topic of fairness in AI. We want to have machine learning systems deliver results that do not discriminate minorities, give at least more or less equal distributions of output for different categories of users. And that is good because it makes people accept technology faster. On the other hand, the same EU AI Act introduces funny procedures of regulation. For example, a statement about model capabilities. Any AI system should go through assessment of its possible impact on people. If it demonstrates unspecified behavior, it should go through re-evaluation again. So here, on the very slippery slope in the area of foundational models, what has been discovered about large language models, the bigger they become, the more they tend to demonstrate those emergent properties like GPT, that was first introduced, was not intended to serve as a translator. And it was capable to do good enough translations. This legislative requirement an obstacle for fast innovation in the EU. The root cause with all the legislation is that laws are written today for yesterday's problems.
Definitely makes sense and is important for legislators to keep an eye on the delta happening from the time when the regulation has been done and how it can be changed and updated.
I recall a very funny situation when Oracle tried to sue Google for use for their API structure. The judge who was to make the decision went as far as learning basics of computer programming, so he could understand what is API and make an informed decision. Eventually, Google had won the case, and the judge concluded that Oracle had built Java API as a set of classes and their structure. It is like having a library catalog, which does not contain information and executable code. It was possible to copy structure, but not implementation, because in intellectual property legislation, what can be patented is an implementation of specific method. It's just structure of methods, not the taxonomy. So sometimes legislation works good for the public.
Driving change in big enterprises is a big thing. And I can imagine that in the projects that you have been driving, you have seen that very extensively, because those are definitely including many stakeholders in the organizations and also on different levels. And from what you have right now described, I have realized that defining the person who would be responsible for the transformation to be driven in the company, the managers are often chosen for that role. At the same time, from what you have described, the success agents can be chosen based on different principles. And those success agents can have different interpersonal networks. And in my words, probably just being very different individuals that when the change is coming, they will probably not find the overlapping points where they will say that the change can't be at all driven and we won't be doing this. I'm also curious on what other parameters might someone think about, and if we were drawing some sort of knowledge graph of such a success agent, what other characteristics could be included for the analysis? Because you have right now mentioned, for example, structural patterns. What are they?
Structural patterns are super powerful. And when building this practice, I was not inventing, I was simply reverse engineering McKinsey practice for organizational change management. Speaking about other characteristics of people who successfully drive change, we can refer to their, as Rogers puts it in my favorite book, Diffusion of Innovations. Rogers was actually the first who noticed that any change is attributed to interpersonal networks and individual characteristics of people involved into the change. There are innovators, people who are eager to accept everything new. It's 2.5% of those folks in our population. There are early adopters, those folks who follow trends, who make conscious decision and investment into new technology, be it technology or just a way of working. Those are usually highly educated and well integrated in the local society. Basically, innovators usually are folks who have far-reaching personal connections. It can be, let's say, it can be a school teacher of mathematics who is exchanging correspondence with other school teachers from other regions, and or even talking to some rock star in mathematics. But in their local neighborhood, they are considered weird folks because they behave totally different of all the population. Adopters are usually very well integrated and they form establishment. So they are also highly educated. They have good economic potential, which allows them experimentation with new technology, and they make conscious decision about adopting or not adopting. They do not follow the hype, but they take the best of being hyped for their benefit. Then there is a group of early majority, middle class. They see that establishment has adopted something new, be it a new language or be it new technology like mobile phones or whatever be it. Rogers actually studied agriculture and penetration of new strains of corn seed in rural America. So this is a universal pattern. Early majority plus innovators and early adopters make half of population. Then there is late majority, and this is just regular folks who see, okay, everyone around is using mobile phone. Why shouldn't I get one? It's convenient. Most of my connections have mobile phone while I'm sitting with my wired phone. That might be an outdated example for our audience, but I have grown up in times of wired phones. And final group is the least or the most disadvantaged or nearly exiled group of people. They adopt innovation after everyone has adopted, and they resist until the very last moment. So when it is not avoidable to live without a mobile phone, they will get it. So attitude to change is generally reflected in their socio-demographic characteristics. And use of such information can help us identify folks that are good in structuring the change. Whenever you plan an intervention, for those who practically do it, I have one advice. Do not focus on innovators. When you come with a presentation to a company, let's say you have an audience of few hundreds, there will be 5 to 10 guys asking questions, eager to test it. Make a note, talk to them politely, but do not stick with them because they like new. They adopt everything new. And in half a year, they will adopt something new again. That's their life of innovators. They try everything new. Stick with establishment, those who follow the initial hype. Once you have established working relations with those folks, you have better chances to get accepted because those early adopters usually give good examples to other people in, let's say, organization, but this can be a broader context. It can be a social group, or it can be a whole country or set of countries.
Well, for us to have success agents, the characteristics are for them to be in the early adopters category or actually be in the wide majority area?
It depends. So to be successful as a change agent, you have to have moderate attitude to everything new. So you have to pick new stuff consciously, not run after everything shiny and new. You have to be well networked, and that makes the person a good change agent. If they are not well networked, then they would struggle to bring change. And it's two sides of one coin. They're well networked because of their social characteristics and attitudes. And that's why they magnify our effort of making change.
One of the applications that I would be probably wishing for in the very near future would be on fake news detection. We are having so many fake videos of certain political figures doing certain things. Of course, we can have lots of articles that are not at all true. Would you expect that we as a society would start building knowledge graphs that are representing the reality and in this way balancing all the generative AI capabilities that we are currently having?
This is a very entertaining topic. I would say that as a society, we have already started building knowledge graphs. Take, for example, DBpedia. There is Wikipedia, which is a commonly accessed knowledge base maintained by community of curators. And there is DBpedia, one of the first knowledge graphs we had. There are some misinformative articles on Wikipedia. There are funny stories related to that. Some guy who was interested in learning some dialect of French that exists in Polynesia learned about that dialect by reading a Wikipedia article, and he traveled to islands just to discover no one knew that there is such a dialect. So yes, we do have knowledge graphs that are publicly maintained and accessed, and yes, they contain information that is not necessarily true, and yes, it is possible to detect such information. There were studies that demonstrated that misinformation on Wiki is differently embedded into the body of Wikipedia. For example, every article on Wikipedia links to other articles. And this pattern of connections makes it travelable, so we can navigate from one concept to another. There is a game in navigating from one concept. For example, Wikipedia distance from Adolf Hitler to cheese is 2. It is possible to detect misinformation on Wikipedia by looking at structure. Knowledge graphs and neuronal methods do help in this. It is very important for our society to not be exposed to false information. It's like when we had this overall excitement about generative AI a few years back, 3 out of 4 founding fathers of contemporary deep learning spoke up. Yoshua Bengio published a very alarming essay about possibilities of AI becoming autonomous. So it was like inspired picture of the new brave world. I had to calm myself down by rewatching a piece from the Blade Runner, the episode with Tears in the Rain. Helped me cool down. Jan LeCun, contrarily, is constantly saying, this is not scary AI. Those are just autoregressive models you should not be scared of. And he is pushing llama models into public domain at super high pace, and it really scares some folks. I personally stick to Geoffrey Hinton's opinion. It is really alarming to have society driven by disinformation. If masses of people are easily manipulated by information which is not factual, that is scary. Once upon a time, my mentee had attempted PhD and her topic was exactly fake news detection. So after a year of studies, she brought up a quite brilliant summary of what is going on with fake news. The root cause is that everyone has their own truth. But there is only one internet, and they meet there. And that sparks lots of problems. I myself have been misled by one know-it-all chat in the domain of statistics. I asked a very specific question about techniques for sample size estimation and spent 2 days searching area which was not existent. And a call to friend have helped. A brilliant astrophysicist had told me, no, that is not existent. Go for power analysis. I said, thank you so much. That's how interpersonal networks help us. Fake news is a hot issue, especially given a recent trend in popular platforms to give up fact-checking, to leave fact-checking to the community.
The whole trend with community notes is indeed very interesting.
And
we are yet to see what and how it will impact us.
Wisdom of the crowd is overrated.
Yeah, definitely. At the same time, I think that we can leave a certain funny exercise to the listeners on the closing of our call, and that would be with regards to finding other distances on Wikipedia that are as interesting as the one from Hitler to cheese. And when it comes to building interpersonal networks, and for the listeners that would like to tap into your expertise overlapping between knowledge graphs and organizational theories, as well as driving enterprise level change, how could listeners reach out to you?
You can find me on School Community, LinkedIn, Facebook, on Singularis Slack, or on the channel, on Telegram channel for Knowledge Graph course we have launched 3 years ago. I think best way to reach me out is through LinkedIn. It's less spammed than email. I have all notifications set to my normal email, and it's a lot of them.
7 digit already? Of unread ones?
I can receive 100 messages a day, yes.
All right, then probably we should stick to LinkedIn. Sounds great, Vadym. Thanks a lot for your time.
AI Ketchup brings the news. Tech solutions users can't refuse. Twice a month, it's alright.